In this video series, we've been exploring how to create a future-proof program by writing a program with design patterns and without if tests. In this video, we need to see if it's actually going to work, because I have the input data directory that we've been processing so far in this video. And to this point, we've had 3 annuity files, 2 employees, and 1 life insurance. But we know we could have any number of any of these files, and they could appear in any order. Well, now we have a new surprise, which is we have a mutual fund file. And if you take a look at this, we might have a ticker symbol, maybe a current price, maybe an average purchase price, and then perhaps a customer name. And the question is, what modifications do I need to make to my existing program to process this file? And the answer is quite interesting. We don't have to touch anything that we already created. As a matter of fact, the program could be running. And we could actually add a new class into the program and it would continue to run. So what would this look like? Well, it's quite simple the way we've set things up. What we're going to need is just a new class. So I take a new class and we're going to name this one Mutual Fund. And we're going to have our mutual fund implement monthly item. And why is that? Well, remember that our monthly runner is looking for a monthly item. So it's going to iterate over our series of files. It's going to take part of the file name, pass it to a factory method called createMonthlyItem, and then that's going to give it back an object and store that object in a variable of type monthlyItem, and then it's going to invoke the execute method. None of this changes. As a matter of fact, from this point forward, you won't see me do any modification to any of these files that I'm highlighting. All I'm going to do is add a new file. So let's take a look. I right-click on Monthly Processor and I choose New Class. I'm going to call this one Mutual Fund. And everything else looks good. I'm going to choose Finish, and then I'm going to say Implements Monthly Item, like so. Of course, Mutual Fund is going to turn red now, and I'm going to say Implement All Abstract Classes, or All Abstract Methods. Let's remember what's in this file. It's going to be a ticker symbol, current price, average cost, and then first name, last name of customer. Okay, easy enough to do. So in the execute method, let me try to give us a little more room to look here. In the execute method then, I'm going to do the scanner trick that we saw before. So I'm going to borrow a couple of things I saw from another class. So scanner equals new scanner, and then we pass in a reference to that file. Okay. Scanner.next, and the first thing is the mutual fund name. So actually, I'll tell you what, let me go ahead and make some attributes up here. Private string mutual fund name, private, let's say float, and then we'll say closing price, private float average cost, and then private string first name, so the customer's first name, private string last name, so the customer's last name. That'll make things a little bit easier on me. And then I can right-click, refactor, and we'll choose our encapsulate fields again. And that will give us the getter and setters for each of these methods. So we go ahead and choose refactor, let it go ahead and auto-generate all those getters and setters, and at this point we can continue on with our execute method. It doesn't know who scanner is, so I import scanner. And now scanner next, well, the first thing in that file was the mutual fund name. So mutual fund name equals scanner.next. And then we're going to say scanner.next float, and that will be our closing price. Closing price equals scanner next float. Scanner.next float, and that's going to give us our average cost. Looks like I need to change my capitalization there. Average cost, like so. Okay, first name equals scanner.next, and then last name equals scanner.next. So once again, with scanner, if you don't have, we covered that in a previous video, but what that's doing is it's just reading until it sees a space. So scanner.next will give us this, and then scanner.next float gives us this, next float again gives us this, next gives us first name, next again gives us the next name, just like so. So we're just about done. We just need to do a system out print line here and say mutual fund We'll say mutual fund closing price, and then we'll say plus closing price plus average cost plus average plus for customer, and then we'll say plus first name plus space plus last name. And I think we missed the mutual fund name again. So let's say mutual fund, we'll do a break here, mutual fund name plus closing price, like so. Okay, so I save, and once again I will point out the only file I have touched is this new file called mutualfund.java. As a matter of fact, take a look. You notice it's green, everything else is black. What that means is that this is a new file since my last commit. The other files have not changed since my last commit. So all I've done is created a brand new class called mutual fund. I have made no alterations to the rest of this program. Let's go ahead and run it without the debugger and see if it works. Let's just see if it gives us the output we expect. I'm anticipating 3 annuity lines, 1 for each of our annuity files, 2 lines for employee, 1 for life insurance, and 1 for mutual fund. So let's do a quick run and make sure that that's what we get. And what do we see? Let me just mouse up a bit. 3 annuities, 2 payrolls for employees, 1 life insurance, and sure enough, take a look. We did get our 1 line that represents this new mutual fund file. Let's take a look at this in the debugger now that we've had a chance to see it run. So the first few I'm just going to run right through because we've already seen an annuity. I'll very quickly F7 in, and you notice when I F7 in and the object type is annuity, you'll notice that it goes to the annuity class. So second one is also an annuity. It goes to the annuity class's execute method. The third object that we're creating is also for an annuity file. I mouse over and I can show you that. When I choose F7, we go to the annuity file to see how to run this execute method. Once again, polymorphism. The variable type is monthly item. The object type is annuity. That means when I F7, we see how annuity works because the object type tells us what will happen when we invoke that method. We go for another round trip, and this time what do we have? The monthly item now is an employee, so we F7 in, and we see the employee logic from the employee class. Once again, polymorphism. Object type tells us we're allowed to call the method execute. Variable type tells us we're allowed to call the method execute, but the object type tells us what actually happens when we invoke that method. We go around one more time, and we're going to see this time we're on a life insurance type. So I F7 to step into that, and we see that we're following the execute logic that's defined within the class called life insurance. Finally, our new one. Let's take a look very closely here. What's our factory parameter? Our factory parameter is mutual fund. Now this is for the new class. Remember, what you're looking at right now, none of this has changed. But take a look. It realizes that the variable type is monthly item, and it realizes that the object type is mutual fund. By using the command pattern and our very flexible abstract factory pattern, it created an object of this brand new class mutual fund when it found this file that it previously didn't understand called mutual fund. So it created that object, and now it's about to invoke a method on this object that only has existed for a few minutes now. So I choose F7 and take a look. Does this look familiar? This is the mutual fund logic that we just wrote within this video. And if I take a look at our output, we'll see, no surprise, I need to look at the right output actually. Let me go ahead and choose F9. But what we'll see when we take a look at the output is that we do get 3 annuities, 2 employees, a life insurance, and a mutual fund, which matches exactly what we have here. I could make 3 more mutual fund files, and they would all process as we would expect. Each of them would be processed with a mutual fund, an object of the mutual fund class. So that's how we can make future-proof programs where if our inputs change, all we need to do is write a little class that handles that input, and the balance of the program does not have to change. let's go back and remember monthly runner. You might remember we used to have a big if test in here where we would say, look at the name. If it's an annuity, create an annuity. If it's a life insurance, create a life insurance. We replaced that if test with this line of reflection right here. If we still had that if test in this method, we would have to alter that method and say, okay, now start handling mutual funds as soon as we started getting these mutual fund files. And that would break our future-proof program because we have to go in and change this infrastructure class monthly runner. But by replacing the if test with reflection here, and by using the command pattern up here, we've completely avoided if tests anywhere in our program. You won't see an if test in any of these classes. So by taking out those if tests, we're able to have a more flexible future-proof program. And now maybe two of the quotes that I started the series with will make a little bit more sense. If you're not using interfaces, you're only using half of Java's potential. Because what happened with our interfaces? We were able to decouple the invocation of this execute method with the 4 different implementations of that execute method. The monthly runner only needs to know what this is. It does not need to know what all these implementing classes are. Secondly, you can judge how well an object-oriented program is written by how few if tests it uses. So here what you see is that by eliminating if tests, we have a future-proof program. Now, a question is, does this work in real life? And the answer is, I had this scenario happen to me back in 2001, almost exactly what we're looking at here. I was working for a payment provider at the time, payment processor at the time, and I was writing some software to handle chargebacks from credit cards. And they told me I would need to handle file type 0 through 9. And the first part of the file name was a number which indicated what type of file it was, 0 through 9. So I wrote this program, and this was the time I challenged myself to try to write a program without if tests. I wrote the program. It started as 5,000 lines when I inherited it. When I was finished with it, I had it down to less than 2,000 lines, and it did twice as much functionality and did not have a single if test. After I released the program and it went live, I got a frantic phone call that said, hey, we forgot to tell you there's actually a 10th file type you're going to need to handle as well. How much do you need to do to make it happen? Of course, I told them it would take a couple of weeks, when the reality is I just had to make this special file called like a 10-file processor. And without even turning off the program, I compiled this file, deployed it, the program recognized the file and was able to start processing these 10 records within about an hour of the time I got the phone call that, oh my gosh, we forgot to tell you, there's another type of file that you're going to have to handle. So that really changed my way of thinking around programming, and that's what I'm trying to demonstrate through this example. So think about that a bit, challenge yourself, think about how to minimize if tests in your program, and think about how to use the design patterns that I've listed here, as well as any other design pattern, to write a future-proof program. I'm curious how it works for you. Let me know in the comments, and I look forward to reading what you have to say. Thank you.